So let's have a look on how we can solve this mechanic question. So this is a Pulley question with forces involved. So a small stone A of mass 3m is attached to one end of the string. A small stone B of mass m is attached to the other end of the string. Initially, A is at rest. So it's not moving. So it's at rest on a fixed rough horizontal plane. Oh, so far so good. The plane is inclined to the horizontal at an angle of tan alpha is equal to 3 over 4. As soon as I see this, I'm going to draw my triangle. If this is my angle, if I use tan, my opposite tan is opposite of adjacent. So 3 is this side, 4 is my adjacent, which is this side here. And the hypotenuse in this case will be 5 if you use Pythagoras, if you want to do it that way. And I'm straight away able to say that my sine alpha is going to be 3 over 5. And my cos alpha is going to be my 4 over 5. This is going to come handy later on, so it's very important that I know how they are, so I can calculate them. So the string passes over a pulley P that is fixed at the top of the plane. The part of the string from A to P is parallel to the line of greatest slope of the plane. Stone B hangs freely below P. The coefficient of friction between A and the plane is 1 over 6. Stone A is released from rest and begins to move down the plane. So I know the movement or motion of A is that way, and therefore B is going to go up. The stone are modeled as particles. The pulley is modeled as being small and smooth. So that means there's no friction in the pulley. The string is modeled as being as light and extendable. Simply means that same tension and the same acceleration. So this is going to come handy later on. And yeah, so using the model for the motion of the system before B reaches A, write down an equation for motion for A. So let's consider what are all the forces for A. So I'm going to use different colors here to represent different forces. So first of all, I know that I have my reaction force of the particle A. I'm going to call this my R. And then I have my friction, given that the friction is always in the opposite direction of motion. So my friction is going to go in that way. And then I have to consider the force the weight of the particle, which will be 3 mg. That's my weight. And I can find the two components in this case here. And the two components, let's call it the component that's perpendicular to the plane. Let's do that in a green color. So therefore, this is going to go down that way like this. And then we have the parallel component to the plane, which is going to go down like this. So let's find what that would be. So my perpendicular component, in this case here, that will be 3 mg multiplied by, this is the adjacent side, so that'll be cos alpha. So I know cos alpha is 4 over 3, so I can use that later on. And the parallel component, in this case here, that can be rewritten as 3 mg sine alpha. So these here are most of the forces I have. So the only thing I'm missing now is the tension in the cable. So the same thing can be applied to the other side. I have the tension in the cable there and have the force pushing it downwards, which will be my 3, not 3, in this case simply is going to be my mg. So these here are all the forces that I have to work with when resolving the problem. So right now let's focus on part A. So part A is telling me write down an equation of motion for A. So I can do this using my formula F equal to ma. So given that the object is moving downwards, I'm going to take going down the plane as my positive side. So which force is, in this case, which force is pushing it downwards? So I can see that will be this force here, the 3 mg sine alpha is pushing the object downwards. So I'm going to write 3 mg sine alpha. I'm not going to substitute any value just yet. So that is the only force pushing it downwards. So what are the what are the forces pushing in the other direction? And that is my friction and also my tension. So those are the two forces countering the force pushing forward. So this is my resultant force, which is my F, is equal to my mass, which is 3m, multiplied by my acceleration, which I'm not sure what that is, so I'm going to use A for my acceleration. So now I can simplify a few things here. So friction, we know that we can rewrite as mu times reaction force. So reaction force is my R, which I do need to calculate in this case here. So my R in this case here, given that that's the only force going upwards, must be equal to any forces going downwards that is in the same direction of R. So in this case, we can see there is a perpendicular component of the weight, which is 3 mg cos alpha, being the only force to counter that. So my R is equal to 3 mg cos alpha. We can simplify down this for my R being simply 3 mg. My cos alpha is 4 over 5. So I can rewrite as 4 over 5. And if I simplify this out, that gives me 12 mg over 5. So that's what I can replace my friction with. My tension at the moment, I'm not sure what that is. So I'm going to leave it as it is. 3 MA, again, I'm going to leave it as it is. So if I rewrite this again, so that becomes 3 mg. My sine alpha, in this case here, I know is going to be 3 over 5 minus 3 mg bracket. In fact, I can write the simplified answer, but given that I'll simplify later, I'll write it like this for now. 4 over 5. Actually, let's write that, so because we still have to do the multiplication after. So that would be my friction is calculated by doing my mu, which is my coefficient of friction of the plane, which is 1/6. So that would be 1 over 6 being multiplied by 12 mg over 5 minus my tension is equal to 3 MA. So if I simplify this out, so 3 mg times 3 over 5, that gives me 9 mg over 5. The 6 and 12 can simplify out, so that gives me 2, that gives me 1. So it will be minus 2 mg over 5 minus tension is equal to 3 MA. So I can now simplify this out to simplify down to 9 mg minus 2 mg over 5, and therefore this simplifies down to 7 mg over 5 minus tension is equal to 3 MA. So this is my equation for the motion for A. That's pretty much it. Part B telling me to show that the acceleration of A is 1 over 10 g. All right, so I need to find what the acceleration is. However, at this moment in time, I cannot do that because I have tension, which is unknown, and therefore the way that I'm going to solve this equation is by bringing in my equation for motion for particle B. So let's have a look on how we can do this. Perhaps let's do part B in a different color so we can show what are the different parts. So for particle B, so let's create an equation for particle B. So this is part B actually. Part B, equation B, again, is given calculated by F equal to MA. So in this case here, again, I'm resolving upwards being my positive, given that's the motion of direction of my particle B, right? So therefore, in this case here, what is the force pushing the object upwards? That's my tension. What is the force pushing the object downwards? That's my mg. So tension minus mg is equal to my mass, which is m, times a. Therefore, that is ma. So this is my equation for motion for equation B, for particle B. So in order to find my tension, I can rearrange this equation and make t the subject. So t becomes equivalent to mg plus ma. And now I can take this and put this back into wherever t is, and helps me solve equation and helps me find what the acceleration is. So let's try to do that. So if we do this in this case here, so let's do sub t into equation A. So this is our equation A. So if we do this, so that becomes 7 mg over 5 minus mg minus mg minus m plus ma is equal to 3ma. So 7mg minus mg, that will give us simply 2mg over 5. The minus sign is applied to both mg and ma. So we subtract the mg, so that'll be minus ma is equivalent to 3ma. So now what I can do is bring the ma to the other side. So that becomes 2mg over 5 is equal to 3ma plus ma gives us 4ma. And one thing that I can see that I can cancel out on both sides is my m's. So that gives me 2. Let's go back to blue. That gives me 2 over 5g is equal to 4a. So my a is calculated by taking the 4 to the other side. So that gives me 2g divided by 5 divided by 4, and therefore 2 over 5 5g divided by 4 gives my acceleration as 2g over 20, and this simplifies down to my acceleration being as 2 and 20 can cancel out, simplify out, so therefore my acceleration becomes 1 over 10g, and this is exactly what they asked us in this case here. And therefore that's the answer for part B. So this is the most critical part of the question. It's worth 7 marks, so it's important that we show all the steps at a time. I know that went a lot slower than I should, but it's important that we understand this very, very well. If you can understand the concept of this question, it can be applied to any other questions you also do. Part C is telling us to sketch a velocity time graph for the motion of B from the instant when A is released from rest to the instant just before B reaches the pulley. Explain your answer in this case here. Well, in order to do part C, this will be if I sketch my velocity time graph. So that's part C. So in this case here, I have my time here and have my velocity there. So in this case, this will look like just a simple straight line. And the explanation is the acceleration is constant. And you must remember, in a velocity time graph, the gradient of the line represents your acceleration. And therefore, the acceleration is constant and is always going to be 1 over 10 times g. And this is how your velocity time graph would look like. So, part D is asking us, state, in reality, the string is not light. State how this would affect working in part B. So if the string was not light and has some weight in it, so you can say the tension in the two equation A and B would be different. That's all we had to say for part D. So as I said, it's very important that the string is light and inextendable. That means the same tension, and also the acceleration is the same across for both A and particle B. So this is the assumption question that you get at the end. So this 1 marker question, always try to catch students out of guard. Students don't pay too much attention because it's just 1 mark, but it's very important that we're able to answer every single part of the question to maximizing our marks in the exam. So please do spend some time getting to know what are our assumptions, how does this affect our answers, because usually those are the questions where students lose marks, and this 1-2 marks can be the difference between an A and A star, for example. So hopefully this question is all clear now. Let me know if you have any questions below. But yeah, so this is the final, this is the model answer on how you answer any questions where you have forces at an incline with pulleys. Yeah, always try to take a step at a time and try to reach to your answer. Any questions, do let me know down below. Thank you.